Hello, welcome for this session, and this is chapter 2, units of measurement. Units of measurement. We are now on section number 2, and we will look at the main ideas here before we proceed. The first one is scientists worldwide use SI measurement. So we will be looking at what SI measurements are and how they came about. We will look at prefixes added to SI base units indicate larger or smaller quantities, and we will look at examples 2, 3. SI base units combine to form derived units. We will see how the SI base units can combine to form derived units. Then conversion factors change one unit to another. We will see how conversion factors are used to change one unit to another. So as you may imagine, or think about some things that you know in your world. Things that you know that you need to measure are very many. So it is just that human beings have to look for measurements for these things, like in physics, people might want to know what motion is, heat, how they can measure electricity, gravity, and so forth. So in science, basically, we have what we call physical quantities, and we use them to measure. So what you have here are but the tools that scientists use when measuring substances. So when scientists are measuring substances, they will use, for mass, they will use a balance. For length, they may use a ruler, and for time, they may use a clock. But how did people really start doing this? That is what we will be looking at in the next coming time. So when we look at speed, for example, we say it is distance divided by time. We will see what that means. Force, mass times acceleration, all these are units that are used by scientists to measure. We will be seeing which ones here are the SI units and which ones are derived units. So in nature, how do we measure any quantity? For example, mass. You think of going to the gym, but you have to know the amount of substance that you will be lifting, what is its composition, and you will use measurements like kilograms, which is mass. We will be looking at the details in the preceding time. Then there is units here, may include kilograms. Kilograms, we will see how they can be smaller than that. The grams, how we come up to get. If you want to measure height of an individual also, like you will need these units. You want to find how something, the amount of it that makes something, you will use mass, and in this case That is, so basically, even distance, the distance we travel, we always have a challenge. We need to know the distance that we are covering. We need to know we need to know our height. Are we tall, or people can use feet, they can use mirrors to measure. So these units are very many here, and they have symbols that represent them. We will be looking at them individually, slowly by slowly, as we proceed. So this is the SI unit system of unit. I mean SI unit. This was discovered in Paris in 1960. That is when this was started. So these fundamental base qualities are what we are calling the SI units, and they are normally 7. SI units are 7. So these are just but symbols. Okay, let's go into the detailed discussion of this unit here. First, measurements are quantitative information. So our measurements are quantitative measurements. Are quantitative information. By quantitative, we mean that you need to look at the numerical values of materials. Then a measurement is not just a number or a numeral. A measurement is not just a number or a numeral. Let's take an example of a chef. Maybe a chef wants to prepare food. Then, in his day-to-day activity, he tells you we use 3, we use 2, we use 1. You are seeing these numbers here. But these numbers are valueless because we don't know what he means here. Is he meaning 2 cups? Is he meaning 2 spoons? Is he meaning 1 sack? And so forth. So that is why, because of these challenges, scientists had to look for a way to dodge them. So measurements represent quantities. Measurements represent quantities. Measurements represent quantities. Quantities. So a quantity is something that has magnitude. A quantity is something that has magnitude. The quantity is something that has magnitude, size, or amount. Size or amount. So we need to know this. So a quantity is not just, not the same as a measurement. A quantity is not the same as measurement. A quantity is not the same as measurement. Is not the same as measurement. Sorry, not the same as measurement. So let's take an example here. For example, you have 2 spoonfuls. So you have the teaspoon, it's a unit of measurement. Teaspoon is a unit of measurement. Teaspoon is a unit of measurement. So the quantity represented by teaspoon is volume. By teaspoon is volume. So we are talking of teaspoon itself being taken as a unit of measurement. But volume is a quantity. Volume is a quantity. So volume is a quantity, and to find this quantity, we have to have a unit of measurement, which is of course represented by the teaspoon in this case. So quantity is not the same as measurement, as we have said. So teaspoon is a unit of measurement. We use it to measure. The quantity represented by teaspoon is volume. So volume is the quantity. Volume is the quantity. So a teaspoon is a measurement standard. A teaspoon is a measurement standard. So that if you tell someone 2 teaspoonful, they will understand what you mean. So this is in the US. So in the United States of America, a teaspoon is a measurement standard. It's a measurement standard. It can be used to measure, and it can act like a unit, Units of measurement compare what is to be measured with a previously defined size. Units of measurement compare what is to be measured with a previously defined size. With a previously defined size. So if you are taking a teaspoon, for example, as being a unit of measurement, then it is defined with the size. It is defined with the size. So nearly every measurement is a number plus a unit. So the choice of the unit depends on the quantity being measured. So the choice here depends on the quantity being measured.